system design, so the basics. So I'll take two parts of it, as I told you. One is the interview part of it, which has four things. The first thing in the system design world is whenever there is some problem thrown at you, any problem for system design. Um, let's take an example. Let's say you want to, somebody tells you to um, do a let's say for HLD, somebody tells you that design a Netflix system, or for an LLD, somebody says a library based system, or like library system, library management system, and all those things. So the first thing that we as people we should see is always we should understand and write down the functional requirements of the system. So when I say the functional requirements, and there are some chats, okay, okay, perfect. When I say the functional requirements, what I mean is what do you expect the system to do? Like, let's say, taking the example of Netflix, of course, it needs to stream the movie. So maybe one of the functional requirements is to stream the movie. Do you want to build a recommendation, like a movie recommendation engine with this? So maybe that. So these are the functional requirements that are there. Now comes up the non-functional requirements. So in the non-functional requirements, the thing is that how much is the latency of the system? Like how fast do you want the system to respond? So this is the latency. How is the throughput of the system? So you have to come up with these numbers. Like there needs to be an expected numbers that you need to come up with. So let's say the latency you can maybe for uh, Netflix movie recommendation could be around, let's say, 1000 ms, 1000 milliseconds. So you can think of such kind of numbers, and there needs to be a reasoning behind these numbers. So and when you come up with these numbers, let's say I want to understand the traffic of Netflix. How do you figure out what's the traffic of Netflix? How much can be how many requests can come to the Netflix streaming service at a single instant at peak is what throughput is. And you have to think of those numbers, because and that needs to be a realistic number. You can't just put in anything or everything in play. So you need to understand how Netflix would or can function. One way, like I can give an example. Let's say somebody asks me design Netflix, and I have to figure out what's the throughput, and it's interview. So you need to understand that you cannot spend a lot of time and effort in figuring out this thing. And maybe what I would do is, let's say, if I'm working from this part of my thing, like if I'm in India, and if I'm considering the APAC side of stuff, because if if there is day or if there is evening in the APAC, there would be morning or working hours in the US time zones. So it will compensate each other. Now, if I see India, India has a population of more than a billion people. So uh, that means I can easily say at max there would be billion folks trying to access Netflix. Now, which part of Netflix and all, there is a lot of complexities in it, and we'll delve into it this thing later in the series. But I'm just taking an example. We need to also form a lot of calculations around it, and there needs to be a proper reasoning. But these are non-functional requirements. Along with it, we always need to talk about whether your system is consistent or available. When I say consistent or available, I mean, of course, the system needs to be both, but one needs to take a precedence over the other. So when I say consistent, it means it should always give you the right answer or no answer. But in availability, it should say that it will always give an answer. Maybe the answer is correct or wrong, that is up to it, that is questionable. So in case of Netflix, we can always safely assume that our system should always be available than consistent, because it's okay. Let's say you there is a title that is released in Netflix and it's available on US. It's available in US, and after 2 minutes it becomes available in India. That's completely fine. But in case the Netflix is not working, so if there is no answer, that would be a bad user experience in the world of Netflix. So for us, in the case of Netflix, it will be always availability taking precedence over consistency. Then uh, comes up the HLD part of the design, wherein you draw the high level design diagram, and maybe the interviewer would ask you the LLD part, wherein it will uh, for a particular component for or for certain things that it will that it the interviewer is actually um, curious about. So he or she will ask you that. Combined with HLD, these two things, the fifth part is the most important and the dangerous part, which is the questions. So that's where design comes into the play, and that's where your experience and your interactions come into the play. You can easily learn about the first four aspects. You can go through a lot of, there is grokking interview, there's a lot of other stuff. But the problem is they'll only walk you through one, two, three, four. The thing is the fifth one, wherein you have to answer certain questions that were asked to you based on the HLD and LLD that you drew. And that comes up with A, interacting, B, actually doing real world problems. So this is very important. That's where like I always tell people that design is all about protecting your like the design that you have made. So you need to be able to answer the or answer the questions that are asked based on on the design that you presented. And there is no right or wrong answer. This is not a lead code problem or data structure problem that you say, you know what, there is a problem and this is the right answer to it, or this is the right type of a solution. Yet you need, yeah, you can solve it in a brute force manner, but DP is the right answer. In the system design world, there are like numerous solutions to the same problem, and all are right and all are wrong. It all depends how you can protect your design. This is the interview side of stuff, and the reason that is this is limited to this particular part is because you only have 45 minutes. So 45 minutes, maybe maximum an hour, and that's where you have to uh, basically try to impress the interviewer, and that's much you can do. But in the real world, wherein you have to solve challenges, there are a lot of other things that you have to take into considerations, and a lot of like there are certain there are a lot of other things that you have to take into considerations, and there are a lot of certain um, how do I say it? There are a lot of uh, like I would say, I'll not say them hacks, but I would say there are certain uh, things that we have taken or I've carved out in my like from my real world examples, real life examples that I'll talk about right now. As to like if you follow these patterns, it'll be easier to navigate in the real world. That's what I can say. I would not say hacks because hacks is not the right word in this manner. But in the real world, we have the most important thing. See, this real world is not to impress anyone, but to run a business. So always understand that there is a business angle in play. And to business, technology is an enabler. And when this is an enabler, the first thing that any business for any project that gets spin up or it's being worked upon, the first thing that comes up in mind for the business is the cost. There are three types of cost in play. One is always the development cost. One is the deployment cost or the running cost of the server, and one is the maintenance cost. So you, as architects, as developers, always need to consider these three costs in play for actually trying to design a system. The other thing that is very important is when you're given a real world problem, or in the real world, even in the interview time, you cannot solve everything. Like if I give you a problem to form a Netflix has been formed from over the years, so you cannot form everything on day one. Like, so same in the real world, the business problems or the business will extend itself, expand itself, the problems will change, anything and everything can happen. So your system should be extensible, because most of the systems that you, or most of the problems that you get in the real world would be very big, very very big. And in unless until you have extensibility in play, you cannot you cannot go back and say, you know what, I today I'm building version 1 of the system, tomorrow I want to build version 2 of the system. This is simply not acceptable in the business world. They would want you to use v1 and extend it to somewhere v1 dash to incorporate new changes. So extensibility is very important whenever you are designing the system. The third thing is, there is something called ideal world, or as I say, the real world of stuff, and there's something called the real world. So the ideal world would be the correct or the most apt design that comes up into the play. But the real world is the design that actually comes to life. What I mean by this is, maybe on day one or on day zero, before you start the implementation, you would have designed the system as the ideal one. But when it comes to the development, you improvise based on maybe delivery times, time to market, and you come up to the real world stuff. So your system from real world goes to the real world. So there would be improvisations that you would do in the real, from the real world to the real world. Then the thing is, once you design your system, so even the real world system or the ideal world system, and you have presented it out and you have a lot of things, you have passed through the design reviews and everything. One thing that you should always keep in mind is that, let's say you have three, uh, let me take an example. Let's say I'm the, like, I have to build something similar to what Netflix has, and Netflix has three major things. I'm taking an example, just I know it has a lot of other things, but let's say it has a recommendation engine, it has streaming service, and what else? Let's say it has fraud service. Now, as the architect of the Netflix, or the owner of as an architect first, I have found that, okay, I need to build these three things. Now, as the owner of the Netflix, I have only limited resources with me, or limited folks working with me. What was the first thing that you guys feel I should prioritize to get the things out, like to get my business running? The constraint over here is that you know what, I have very limited set of resources. So what is the first thing that you guys feel? And you can post answers in the chat, or you can, yeah, talk about, yeah, there are answers coming in the chat. Let me open it up. Streaming, streaming, streaming. Perfect. Everyone is talking about streaming. Anyone feels there is some other service that could come up? No, because unless streaming comes into the play, the business cannot run. That's the reason. If you see, I'll take this case study of Netflix only. um, they have very good user interface, UI or UX, I can say. They have good streaming service, but the new system that Netflix had, the fraud one, which is the IP lookup, like you can't run more than one TVs from a single IP, like more than one TVs from different IPs. This thing came very late, because when Netflix realized that there is a password sharing happening and people are using that, that's where they added this feature. But the first set of the order was to always get the revenue. Unless you don't have revenue, what will you build this feature for? So that is where we say that you need to have a minimum viable product, or MVA, carved out. So as architects, you should know what is the minimum viable product in this and how do you carve it out. That's very, very important, because this will help you A, in time to market with the set of resources, and B, improvise along the dev cycle. So this is very, very important with this thing. So these are certain things that we wanted with the real world stuff that you need to keep in mind while actually designing these systems. So um, and one more thing, always remember that whatever problems that you get in the real world, in the interviews, it's very standard set of problems, but in the real world, the problem's gonna be very, very vague, very vague. And as in when you grow in your career, that vagueness keeps on increasing. So system design is all about, like, the 50% of the challenge is solved when you understand that the problem is vague and you've figured out the first set of requirements for that particular problem. You won't get all the set of problem requirements from someone, so you have to understand that fact. So yeah, probably this is what I generally keep in mind with my real world problems that I get to work on.